Okay, so we're finding concavity and points of inflection. And we're just going through and learning this stuff by me working examples out and you studying the patterns. Okay, so we have 1/4 x to the 4th minus 2x squared. You know, that's how I found math to be much easier to learn, and that's just watching somebody work examples out. And I always hated when the instructor talked about the theory all class and then gave us homework on the problems and we had to try to figure out how to work them out, even though I guess there's nothing wrong with trying to stretch your brain, but it seemed like I never did get enough examples worked out in class. Okay, so what we want to do here is want to take the first derivative. Let's find the first derivative. And let's see, taking the 4 out front, 1/4 times 4 is 1. And so you're left with x to the 3rd minus, and then bring the 2 out front, so that's 4x. So at this point in the game, I'm hoping that you know how to take some simple derivatives like those. Now what we want to get to, though, is the second derivative, because that's going to indicate, give us our concavity and points of inflection. At least most of the time it will. Sometimes we can't do that, though. Use the second derivative, and we got to go back to the first derivative, but I don't know if we'll talk about that or not. But anyway, let's see, that's a 2 there and then minus 4. Okay, so we want to do is take that second derivative, set it equal to 0, and find the solutions to this equation. And so that's going to end up being 4 thirds square root plus or minus. Okay, solving for x in this equation, this is what we should get. And of course we can simplify this down to 2 over the square root of 3. Right, square root of 4 is 2, and then you have square root of 3. And we could get this radical out of the denominator, but I think I'll just leave it there. What the heck. Okay, so here's two possible points of inflection where x is equal to plus or minus 2 over the square root of 3. At least that's our x values. We'd have to find our y by plugging those directly back in to the original function. And why don't we just go ahead and do that and get that out of the way right now. So f of 2 over the square root of 3 is equal to, so we're plugging these back into the original. And that's to the 4th power minus 2 times 2 over the square root of 3, and that's squared. Now I'm not going to go through all the arithmetic here and showing you how to figure out how to get all this. I'm just going to write it out right here. So that should be negative 20 over 9. So hopefully you can work all this out and get negative 20 over 9. Okay. Now if I were to plug in a negative in here, if this were a negative right here, because we got two solutions, we got a positive one and a negative one, because this is raised to the 4th power, it's not going to make any difference. Our answer is still going to be the same, negative 20 over 9, if we were to plug in the negative 2 over square roots of 3. And that is because this is raised to the 4th power and that's squared, and right, take a negative raised to the 4th power, you get a positive, and a negative squared is also positive, so that's not going to change any at all, right? So I'm going to say that our points of inflection are going to be 2 over the square root of 3, comma, negative 20 over 9, and negative 2 over the square root of 3, comma, negative 20 over 9. Okay, so those are our points of inflection right there. Now what we want to do is find our concavity.